All right, 3.2, 3 ways to prove triangles congruent. This is a very, very important section, so please take extremely good notes. And if there's anything that confuses you, ask me right away in the class the next time you see me. All right, so let's start off with included angles and included sides. In the figure below, angle H is included by the sides GH and HJ. So angle H, which is right here, is included by this and this. Side GH, this right here, is included by angle H again and angle G. What are the sides that are included by angle G? Well, we've got GH, we could also say GJ. So if you haven't figured it out by now, when we say included by, what we mean is in between. So angle H is in between segment HG and segment HJ. So whenever it's included by, we mean in between. Okay, and it's important to understand that because we're going to be using the word included by rather than in between. All right, so let's start off with the 3 ways that we're going to be able to prove triangles congruent. So the SSS postulate. SSS stands for side, side, side. So proving congruence between triangles can be difficult, but there are some special properties that allow us to prove congruence between triangles, comparing only 3 pairs of corresponding parts. So remember, there are 6 pairs of corresponding parts in 2 triangles, 3 angles and 3 sides. So one of these consists of using just the 3 pairs of sides of a triangle. So say you had 3 sticks of varying length, assuming any 2 were longer than the remaining one. Remember that whole thing with triangles. The sum of 2 sides has to be greater than the length of the third. So how many triangles could you make? The answer is only 1. Go ahead and try it if you don't believe me. And this is a special property of triangles. Here's our postulate. Remember, you use these in proofs. There exists a correspondence between the vertices of 2 triangles such that 3 sides of one triangle are congruent to the corresponding sides of the other triangle. The 2 triangles are congruent by side, side, side. That's a lot to write. I'm not going to expect you to write that out in a proof. You can write out just that. Okay, but make sure that you understand it. All right, so like in this problem here, suppose we had to prove that triangle GHJ was congruent to triangle GKJ. Now notice how I have these ordered. G, H is the outside angle here, K is the corresponding one over here, and then J is the shared point there. So by reflection, if we were to reflect this over GJ, H would match up with K. So just keep that in mind. That kind of goes back to what we were doing yesterday. So our proof would look like this. We've got our statement and reason. 1, GH is congruent to GK. That's a given. Segment HJ is congruent to segment KJ. Now look how I ordered that. This here first and then J. And since this is the congruent part, we have to list that first. And again, J is the second part, and that's a given. And then we can say that GJ, this piece right here, is congruent to itself by the reflexive property, which you learned yesterday. So finally, we can prove that triangle GHJ is congruent to triangle GKJ by side, side, side. Because this is congruent to that, this side is congruent to that one, and this side is congruent to itself. So that's how that kind of proof would look. Now let's get to the SAS postulate, side angle side. We can also use only 2 pairs of corresponding sides of triangles if the angles included by, in other words, in between the 2 sides, are known to be congruent. And here's the postulate. If there exists a correspondence between the vertices of 2 triangles such that the 2 sides and the included angles of one triangle are congruent to the corresponding parts of the other triangle, the 2 triangles are congruent by SAS, side angle side, which again, this is all you have to write in your proof. See, I did that back here. SSS for side, side, side. Okay, same thing here. All right, so remember that the congruent angles must be included by the pairs of congruent sides. So we've got this side is congruent to that one, this side is congruent to that one. So the included angle, which are shown to be congruent, is what we would use to be able to prove these triangles congruent by side angle side. And if you were looking for what kind of transformation this is, this would be a slide. Okay, my lines aren't perfect, but you get the idea. That's just a little FYI, not that that would be included in your proof. Okay, and finally we have the angle side angle postulate. Okay, we can also show that two pairs of congruent corresponding angles and the included corresponding congruent sides of the two triangles can prove two triangles are congruent. God, this sounds really wordy, doesn't it? At least I'm not as monotone this time around though. So like I could read this postulate. If there exists a correspondence between the vertices of two triangles such that two angles and the included side of one triangle are congruent to the corresponding parts of the other triangle, the two triangles are congruent. Or you could just say ASA, angle side angle. Okay? Hopefully that made at least one of you laugh. So, again, this may not be your longest video, but we will be spending quite a bit of time in class going over the sample problems. That's why I put day 1. Day 2, there's not going to be a video so much as tomorrow when you come into class, we're going to be doing a lot of the sample problems, and then the problems out of the book that you do on your own will be done the following day. So you'll get kind of a nice break. So this is going to be it for your videos for the week. So just remember, this is one of the most important things to learn this unit. So I want to make sure that everyone not only understands it, but can use it properly. So to kind of see where you're at with it, see if you can do the next 2 problems. If not, that's fine, but come to class with those questions. So here's the first problem. You're given that segment AD and segment CD are congruent, and that B is the midpoint of segment AC. Prove that triangle ABD is congruent to triangle CBD, and this should take 5 steps. Just as a hint, go back to your definition of a midpoint, and that'll help you out here. So that's the first problem. Pause it, write it down, because I'm going to move right on to the second one here. Okay, now we are given that angle 3 down here is congruent to angle 6. Okay, and we have that segment KR is congruent to segment PR, and that angle KRO is congruent to segment PRM. So we need to prove that triangle KRM is congruent to segment PRO. Alright, now this one is going to be a bit longer and should take 8 steps. I don't expect you to be able to do this. If you do, I'll give you some extra credit, because bonus, kudo to you. That's fantastic, and you've almost mastered this then already. So anyway, like I said, come to class tomorrow with questions if you have any, which I'm hoping that you will. That is all.